So good morning everyone. Today we will, this is basically third lecture in applications development, and we build upon on the previous knowledge. Previously we were talking about structures, sequence, selection, loops, and today we will talk about modularization, hierarchies and documentation. Okay. Before going to today's lecture, I just want to go through assessment 1 and provide you some information. In assessment 1, basically broadly you have to do two tasks. Okay, the first major task is you have to receive the input information from the form, okay, and you need to validate that information. If there is something blank, you have to print some message that information, the field you submitted does not contain information, or format is incorrect, okay, or the range you enter in the field is incorrect, and so on. So that is the validation part. And second is information processing. When all the information that is being submitted from the form is correct, then you can basically process that information. How many medals have been received by a player? How many medals basically are won by a country, and so on. Okay. So these are two broadly two tasks in your assessment. If I go to assessment, and if you have gone through the brief, so this section basically talks about the validation of information. Okay. The simple validation can be done using if statement. If something is blank, you can prompt the user, please enter this value. In today's lab, there will be some functionality you need to write to cater for blank fields. Okay. In similar fashion, you have to basically do validation on all the information which is mentioned over here being submitted by the form. So this is first part. And for this part, as I mentioned, you can write if statements. Okay, there are a couple of statements which you will see, which I have written in the lab to see whether the values being entered by the user are numerical values or string values. So there are a couple of if statements you will see in today's workshop. But there is another way which is available to validate the information, and that is basically regular expressions. Have you heard of regular expressions before? Anyone? No? So these are basically, you can define a pattern, and using the programming language you search for a pattern in the information which you want to validate. So we call them a regular expression. So on your Blackboard website, if you look at this section, I have provided you some links about regular expressions. Okay. For example, there is one example which I have provided to you has implementation of regular expression that you can use to validate the information. I can quickly show you the code. So this is the code. If you download that file, add it to your solution and run this file, you can see what output it will produce. Okay. Pardon? Looking for a match. Yeah, looking for a match. So we are defining a pattern, and that pattern will get executed on the input information.
And if the match doesn't contain it, won't execute.
Yeah. So this is a regular expression. So you can see over here, this is a pattern. Now you may not be able to understand, but I have provided you some links that will provide you information. What does it mean? What these brackets mean? Okay. What A to Z mean? What this /D mean? What plus sign means over there? But this is a regular expression. This is a pattern. Against that pattern, you can validate the string. For example, in dates, we need a well-defined pattern. So we can define the pattern that first two digits should be from 1 to 31, and it all should be only 2 digits. It should not be 4. Year should be 4 digits. If user enter 2 digits, user should be prompted for 4 digits, and so on. Okay, so this is one example which I already provided to you. This link basically provides information about this language in detail. But if you look at this cheat sheet, this provides you information with, about how you can implement it, some implemented examples. Okay, and these are mostly, and you can see this is a symbol that is used to in a pattern to say that this is starting point. From the starting point, there should be a THE word over there. If you are trying to see whether the string is starting with the word or not, you can use this pattern. So this is one pattern. So in short, there's a lot of examples available over here, and again some examples. There's try it link as well, where they basically you have an interface where you can change this expression. You can see how does it get matched, and you can play around. Okay, so this is again very excellent web application where you can define you can put your string over here, you can define expression over here, and it will tell you whether pattern is matching or not with the string. Okay, so do go through these information depending upon what you require. So there's a lot of information, but if you are trying to validate a string that should start with certain specific letter, then you can come to this website and see where is there any example that basically checks for specific letter in start of the string, and then you can test it and then apply in your code. Okay. Similarly, regular expressions are supported in almost every language. You can have regular expression in JavaScript, you can have regular expression in Java language, you can have C#, PHP, everywhere, because this is it's language in itself, pattern language. So again, over here you can see that if you write something like this, it is looking for a number which should range from 0 to 9. Okay. If you are looking for 4 numbers, you can simply repeat this as a pattern. Okay. So go to these information again. If you Google, you will find a lot of information on regular expression. Very good examples you can find on the internet. So in short, in this week you have been introduced to regular expression through these links, and you can start working on your first assessment by validating the input information. Okay. And after that we will do arrays on 5th lecture. So once you have validated the information, everything is fine, then you will basically put that information in arrays, and you will use arrays to compute different information. You can count how many medals a person has received. So using arrays you can do that functionality. Okay. There's another one thing which I want to share with you guys, that in this course basically there's diversity of students. Some of you maybe have very good programming experience, whereas some of students it's first time for them to get experience of web development. Okay. So for assessment, arrays would be fine. If you write procedural code the way we are doing in lab, it's fine. But some of you knows about classes, how to create classes, how to create objects, then I would recommend you to use that, because it will again improve your programming skills. So I can quickly introduce to you how to define class if you're using ASP.NET inline embedded codes scheme which we are doing. Similarly, in script tag that should be defined on top of the web page, you can define a class. Okay. Class has some public access identifier, a class keyword, and the name of the class you want to have, and then you can define method in that class, and then somewhere down you can make object of that class, and you can use that class. Again, it's not mandatory for the students doing first assessment. It is only for those who knows about object-oriented programming. Okay. I would recommend them to follow this approach. Again, there are no extra marks for this. Okay. There are marks for creating functions. As long as you're creating functions, that's fine. But if you do this, this will be good learning experience for you. So this is how we create classes in PHP and can make use of them. I also have one example in PHP. So this is how we define classes in PHP. We don't have public access keyword over here. Simply we can use the word class, class name, and starting bracket of the class, ending bracket. And then we use function keyword to define a function, name of the function, and what the function does. Over here, this is how we create an object. $sign variable and new book. We don't need brackets in PHP when creating object. And this is how we call the method. Instead of dot, we have this arrow sign. We basically add one dash and greater sign. It will convert to arrow sign. Yep.
In general, in this unit, should we be concerned with both PHP and ASP.X, or focus on one or the other?
You should focus on both. One of the objective of this course is to basically expose you to different programming environments. So PHP and ASP.NET, these are two different programming environments. Each have its advantages. Okay, the syntax is very much similar. There are a few changes like the way things are defined. Otherwise, syntax also very similar. So you need to do programming in both in first assessment. In second assessment, we will do only ASP.NET. Okay, so in first assessment, you need to do both. Yep.
That dollar symbol, is that just the defining variable?
Yeah, in PHP, we define the variable using $sign. So all the workshops, especially from second onward workshops, the one which we did in ASP.NET, you are supposed to do those workshops in PHP as well. Okay. Pardon? Yeah. So do those in PHP as well. As I mentioned, syntax is very much similar, so it will not take much time for you to implement that. So in short, in first assessment, you need to do implementation using both languages, PHP and PHP 7 version we are using, and ASP.NET using language of your preference. It could be C# or VB.NET. And those of you who knows about object-oriented programming, I would recommend you to follow object-oriented approach. And for those who don't know, don't worry about it. Okay, you just follow the approach we are doing in the labs. Okay. So anything regarding assessment 1? Any question? Yep.
So the assessment we need to do in Visual Studio, is there any like alternatives we can use to Visual
For which? For ASP.NET?
Yeah, any like other like IDEs we can use, or do we have to use Visual Studio?
Visual Studio is the best one. Otherwise, there's one, you can use Dreamweaver as well if you want.
Which one's that?
Dreamweaver, Adobe Dreamweaver.
Oh, Dreamweaver.
Yeah, you can use that one as well. Yeah. Anything else? All good? Okay. So that was regarding assessment 1. Now we can start today's lecture. So in lecture 2, we discussed about structure in program, and we saw that there are 3 building blocks: sequence, selections, and loops. And using those 3 building blocks, we can do many things. Okay. Today we will go, and we also identified at the end that we do need to create modules. When we are trying to identify a structure in our program, we come across a situation, we see that things are being repeated in the program, and that basically led to the concept of modules. So we will look at the advantages of modularization, how to modularize a program. When we create modules, definitely those modules need to interact with each other. When we have split the functionality into different modules, then how those modules access the variables. Okay, because previously if we don't have modules, accessing the variables is quite easy. Everything is global, you can access them. And then how to depict them on the your flowcharts. So in short, softwares are getting complex, especially in today's when we have huge amount of information getting pumped into the information systems. We need the software that should be intelligent and provide us insight. So complexity of the software is increasing day by day. Okay, so can someone tell me what's the definition of software? How we define a software? Structures around? So these are a set of instructions basically. So does it fulfills the definition that is being required by academia industry? Is there some element missing? Is it just set of instructions that we classify something as software? What else? Series of tasks. Okay, again they are instructions basically.
Is it that it can take input?
Again instructions. Documentation. Set of instructions plus documentation equals to software. If you look at the definition of software, it basically talks about again the code, set of instructions, and documentation. Okay, so that is the definition of software. So we'll talk about software, some modularization concepts, and then we'll also talk about documentation of software. Okay, and we will try to understand why they are important and how they are being used in the programming process. So modularity, we all know that it helps us to solve big problems. Why? Because we are able to divide complex problems into simple problems. And we all know why we do it. Because it gives us better understanding. If you are working in a team and you have been given a task to arrange some concert, you can identify one person who will be a team lead, and that team lead basically can identify 4 or 5 person, and each person would be doing some task. The details of task would be known to that person, but overall the team lead will be looking for results. Okay, so that approach basically help us to tackle big problems. And divide and conquer strategy, we all know very well, especially if you have done system analysis course. How many of you have done system analysis? Almost all of you. So divide and conquer, you know very well. So this scientist Nicholas, he is basically designer of many programming languages, and most famous was, I think, Pascal. He basically said that program actually gradually develops. When you start writing, you basically step by step code your logic, and that logic basically eventually get refined to a program that provides you the objective you want to achieve. So you will start with some broader goal, you write few instructions, and then you drill down to finer details in order to achieve the overall objective. So if we have to develop a program for banking transactions management, for example, so what do you think, how many modules we could have, what possible module we could have in this program? Or even one module is enough, is banking transactions. We don't need modules, sub-modules. Pardon? Speak loud. Sorry, I can't. Customer, yes. Customer is the one who is doing the bank transaction. So management of customer could be a sub-program, function, sub-module. What else? Transaction itself. This is entity, and we can it would have many attributes, many functions can act on that transaction. That could be another sub-program, sub-module. Those two are enough.
Something that updates the database that tracks the accounts or something like that.
Transactions module can do that, or we need some other module. We can have a separate module for database management, and that module can be used in transactions and customer management to achieve certain functionality. Okay, so the different ways we can do it. So we can have for transaction, instead of one transaction module, we can have deposit and withdrawal transaction. So maybe banking transactions, deposit and withdrawal. Okay, we have print statements, a reporting module, or maybe we need print history. So this way we can identify some modules. So modularization basically breaks a program into modules, and each module is a cohesive unit that provides you some functionality. And in the last lecture, we basically identified that structure is very critical for, especially when you are doing planning out the logic of your program. And while doing that, we identified that modules are also very important structure in addition to sequence, selection, and loops. Try to identify them, and then you can use them in your program, and you can also depict them on your flowchart. So this is especially, as I mentioned, in today's environment where software is getting complex, you have to divide your program into modules. So this is not optional now that, okay, you can have one file doing each and everything without any function or not. So we all know modules, functions, they are critical in today's nature of complex nature of softwares. So we all know modules, functions, again in different languages, different words are being used, but semantically they mean the same thing. They provide us modularization. So what are the advantages we are using, we are achieving using functions, modules, subroutines? Code reuse. This is one of the biggest thing. We want to reuse the code. Okay. For example, if you want to validate 5,000 input fields for just whether they are string or not, it's not feasible and not possible to write 5,000 ifs to validate that. So you need some functions that can do this job. 3 or 4 lines enough, or no matter how many lines you need to validate. So this is code reusability. What else? Maintenance. How maintenance?
You only have to change the one module to affect all the other modules.
Yeah, and the guy who basically do develop and maintain software, they know it very well. That software maintenance is one of the key area where most of the efforts were basically put on. And if maintenance is difficult, you're not able to trace out what the bug is, where it is, then it's nightmare. Okay. What else? Readability, yes, conceptualization, readability. By looking at the function, you can see what this program is doing. So it increases readability of your program. Teamwork. Yep, teamwork as well. If reusability is there. So these are the few advantages as we mentioned, and we will go through them one by one. Provide abstraction, readability, teamwork, because of that abstraction and so on. And so these three we identified, and the last, which we have been emphasizing from the lecture 2, that it helps to identify structure in your program. Okay, while you are planning your logic, it helps you to identify structure in your program, appreciate the structure, and it conveys meaning very clearly. So abstractions, we all know models give us abstraction, and through models we can better brainstorm ourselves. Can you think of some real life example where we use models to better understand the problem? Can you think of any real life examples where we use models to try to understand the problem? Weather forecasting. That's one example. You build a model with whatever information you have right now, and you try to understand what would be the future. Okay, so this is one example. Anything else? Construction is the best example. Before building the structure, what you do, you build a model, try to see where it will be exit, how many stories will be there, what support structures are required, and so on. Once the model is finalized from engineers and all the stakeholders, then you go and build the building, or maybe you take further steps. So abstraction is a very powerful concept, and in software and system analysis and design. Analysis and design, again you're making use of use case diagram. That's abstraction. You identify what are the possible functionalities the software will do, and client can look at those use cases and see, oh, it's all perfect, and then they can sign off the form, and you can start the project. So abstraction basically hides away all the details which may not be important right now, and it helps the people to concentrate on the problem, and if it is complex scenario, models make them easy for understanding, for deliberation, and for discussion. Okay, because the details which especially in when you're working in a team, all the details are not relevant to each and every one. Engineered details regarding engineering, they are only concerned with the engineers. The other people who are not engineers, those details doesn't matter to them. But the overall model is important for many stakeholders. Okay, so models basically hide away those details, and the people can focus on what they are required at that particular instant of time. This is another example of doing task in daily life. With the abstraction, you can see you can easily organize yourself. I have to do these 3 tasks. Okay, but if you go in details, then definitely without abstraction things will be tricky. So you don't start this in this fashion. You start in this fashion and then go towards the details. Okay, once you are able to schedule these activities, that in what order you need to do, then you go and work on for the details. As one of your fellow students mentioned, that it helps to work, especially for a team, to work on same project. Once you are able to identify the modules, then those modules can be divided among the teams, and within teams they can be divided further depending upon how complex the program is. Okay, you may have one team working on authentication of the users and input validation. Okay, and within this team, if this input validation is for maybe 20 forms, then maybe 4 or 5 people are working on that task. They can further divide it depending upon the nature of business they are involved in. Similarly, team 2 can work on this product management, team 3 can work on user management. So once you are able to break down software into some level of abstraction, some first hierarchy or second hierarchy of modules, then you can give it to different teams to divide it further. Okay, and those teams can drill down and bring in and code the finer details that were not required at initial start of the project when we identify the overall modules. So it significantly reduced the development time because we have teams working in parallel. They don't need to wait for each other. But there is one challenge over here. As they are working in parallel, these modules eventually needs to be plugged in with each other and give us the overall functionality. So what is the challenge over here? What do you think? When different teams are working together, what important aspects they need to take into consideration while they are doing their work? Keeping in mind these modules need to be plugged together. They need to be integrated together to achieve the overall functionality. But they should take care of while doing this.
Like keeping a standard across all the different modules.
Keep the standard across all the modules. These modules need to communicate with each other. And they should have well-defined interface. Okay, interface is basically, again, what information should this module will forward to the next module. Will it forward the customer information? Will it forward the product information as well to this module? So what input required by each module and what output it will produce. So input output information is very critical over here. No matter what is done within that module, that doesn't matter. That's not a matter of any concern. For example, how this product management is being implemented, it does not affect anything over here, input validation. But what input validation has to give to product management in order to project management to work is very critical. So the communication is very critical. It should be well defined. It should follow certain standards that are being laid out by the organization. Okay. So we saw that functions, modules, they help us to achieve reusability of code. And mostly we need a reusability when we have functionalities like error trapping, user login or authentication. These are very common functionalities which we may need across different projects maybe, or different systems in a certain systems. So for example, if you have login module and the organization is using 3 systems, same login module can be used to authenticate a user and then it can be redirected to respective systems. So we only need to do configuration over here. Rest of the task of authentication is on this module, this function. So this is the best use of reusability. From reusability stems reliability. How come the code which you are reusing is you can take it as a more reliable than writing a new code? Why? Why the reusable code is more reliable generally than the code written by a programmer? What do you think? Because it already proven to be working. It has gone through all the cycle of design, development, testing, deployment, and it has been tested over a period of time, maybe 3 years. Different projects, different subsystems have used this module. There is no error. So it basically brings in reliability. Okay. And as your fellows to mention about the maintenance. So if there is something wrong, if your authentication module is not working, then you know where you need to look for. It's not the project management, it's not the user validation, it is only the login module. You need to basically look for the bug. And once you fix the bug, only that module needs to be delivered to shipped to the client. Just this is a small patch. Run this patch, your code will be working. Not the entire program, entire system you need to send to the customer. So it's very easy for looking for the problem. So code maintenance become very easy. It become very efficient. Running of software will be efficient as well, especially for those who have taken operating system course. It's one few lines that will get loaded and it will do all the tasks. But code maintenance is one of the biggest challenge in software engineering. And if you following modular approach, you are more following this functions-based approach, then it will be very useful for you, very easy for you to maintain your code. So this is again example of authentication module. Authentication module is responsible for authentication of all possible users that interact with the system. It's possible. And this module is responsible to identify what sort of user it is. It is a staff or it's a client. How you can do it? There will be some information in a database with which basically can tell this module that this is a staff, this is a member of casual staff, this is a student, and accordingly this module can authenticate and redirect user to specific subsystem. Okay. Have you heard of single sign-on? So again, these are services that authenticate the user, and once user authenticated, it will be redirected to the system which he requires, and he don't need to log in into the subsystems again. Okay, so that's the concept of single sign-on. Similarly, we could have error management module. Now it's quite possible that you manage the error in input validation the way you will do in your assessment 1. So you are validating the input and you will be printing something on the form that your name field is blank, your date format is incorrect, and so on. You can do it over here. Similarly, project management can manage their errors over here. Users errors can be managed in this module. That's perfectly fine. Easy to update the code. If user field has been increased, over there you can add some lines of code to manage the new field, how information would be read. So this is one way. Second way is, why not you write a specialized error management module that is responsible for management of the errors, but each of these modules basically then, if error get triggered, needs to communicate with error management module, and error management module will then basically tell the user that this error has happened. So in that case, you have to define some schemes, error code. So you have to define all possible errors in your system, and once some errors happen, input validation module, for example, can send the error code to this module, and this module will know what sort of error it is, what I need to do. Do I need to shut down the entire system? It could be some cyber security attack, and the error code said it's high risk attempt, and this module can maybe shut down the entire system, or depending upon situation, things can be managed. So in short, we have one error management module that can handle all possible errors in a system. So you don't need to go and fix, update your code of error handling in those modules. You just need to fix things over here. Easy maintenance, efficiency, reliability, reusability, and so on. So modularization makes it easier to identify structures. In previous lecture, we did that exercise where we identified that now we need modules in our program, especially the dog example where dog was running again and again, and for that we basically identify that should be captured as a module. So especially the new developer, what they do by following that exercise, they try to basically combine several tasks in one module. Okay, this is quite possible, especially for new developers. So you have to be very careful when you are designing your system and you are trying to identify a structure in your program. But experienced programmers, they basically modularize, identify modules in the program to achieve better abstraction. Okay, once they are able to achieve abstraction level, then they better deliberate on the problem, and they can identify how these should be distributed among their teams and so on. Okay, so in a new developer case, they have a function of login, but that login is very specific to one system and cannot be reused anywhere. Okay, but if you have done modularization, keeping in view the abstraction concept, how modules should be divided, keeping in level of functionality, so that few modules which are general in nature can be reused across various systems, then you are able to identify the structure as well as achieve reusability. So in this example, we basically have a structured problem. Okay, if you see over here, and this is the case you will be codifying today in your lab as well. So this is a simple payroll program in which you have a condition that if hours work is greater than 40, then there is some logic you need to do. If it is not, then gross pay is basically calculated in this fashion. Just multiply the number of hours worked with the pay rate, and you get the gross salary. So if it is greater than 40, then you need to look at whether their staff is salaried staff or not. If it is, then there will be no overtime payment. But if it is not, then there will be some extra rate we need to pay for number of hours extra that guy has worked. So number of hours worked minus 40 will give us some extra hours. We multiply it by 1.5 and we are basically calculating overtime pay. In this case overtime is 0, in this case there will be some amount, and that amount will basically be used to calculate the gross pay. So this is a simple structure. It's perfectly fine. We can see there's selection over there, selection if else, everything is perfect, and then eventually it will be ending. So there is entry point and there is exit point. But it can be structured in this fashion as well. So instead of having those selection over there, we can have a module of overtime, and that module basically we can capture this functionality, and this is in your lab as well. So in most of the programming languages, I'm sure you have done C++, you have a main program, and your basically compilers start from the main program and go on from there. In Java, you also have a static void main program. Okay. In ASP.NET, using web forms, which we will do in second half, there are certain functions which get triggered when a page load. We will look at the page load events in second half of this course. So in most of the programs, there is a main program that contains the main line logic, the overall logic that will be calling the modules and so on. In case of PHP, it is not the case. You don't have main function in PHP. So PHP interpreter basically start looking at instructions from top of the page, and as soon as it encounters these tags, it will start executing that code. Okay. If that is a function, then it will not execute that code. It will go to the instructions which basically are outside of the function. So these are the few first line. This is the first line that interpreter will basically execute. So you can see that it will print. You can use echo statement or print statement in PHP. You can use brackets. Without brackets, it also works fine. So you can see I have a sum function over here that is taking 2 inputs, and it is returning a number which is sum of 2 numbers. And when I'm calling this function, this module will get triggered. Control will flow over there. It will combine. It will add up 5 to 10. Z will contain 15, and 15 will be printed over here. Simple. Similarly, in the same way I'm calling it second time and third time. You can also have this example. It's uploaded on the Blackboard as well. Okay. So this is how in PHP things work. This is the main logic over here. The way we have certain rules for naming the variables, similarly we have rules for naming the modules, functions. Okay. For example, if you look at this one, is it a legal name? Yes, because it does not have any space. So rules for module name should be, it must be a one word. It should not have any space. It's better, it should be meaningful, and it is followed by parentheses. So these are the few rules which you need to follow. So in this case, it's meaningful, it's legal, it's followed by brackets. So this is okay. What about this one? Calculate gross. Is it legal?
Yeah.
Yes, it is legal. Is it meaningful? To some extent, depending upon for which software is being implemented. And this is illegal because there is space over there. Okay. So we need to follow those rules when we define a function, and depending upon language, there will be different constructs. For example, in functions defined in PHP, we don't need to tell the return data type of return value. So we start with function name, brackets, and so on. But in case of ASP.NET, we have to specify what should be the return type. So we start with public, int, get number, brackets, and so on. Okay. So from language to language, few things may vary. So we have seen that we can divide a program into modules. When we divide a program into modules, we are careful what information one module will convey to another, and what second module will produce an output that will be consumed by another module, and so on. So in this case, we can see that one module is calling another module. Okay, one module is calling another module, they are communicating with each other, they are giving some value and getting some thing in return. So we can capture this logic in flowchart as well, and it is depicted on this slide. So we have start point, end point, we define certain variables, and then this parallelogram basically tells us there is input or output operation. Then this is shows that this is a module call, and we can define this module in this fashion. So in this case, module should have some return or exit instead of stop symbol over here. Okay, and module should also have a unique name as well. Okay, so things would be called, something would be returned, and so on. Your main logic will continue to flow. Okay, and this is a pseudocode. So as I mentioned to earlier, when this module will be called, control will flow to the function no matter where that function is defined. Okay, so on the top of the page, or maybe it's in the class or whatever, wherever it is being defined. After executing those values, flow again will come back to this component, and from there main logic will continue. I have an example uploaded as well on the blackboard, in which I have certain function. I can show it to you quickly. This one. So in this case, if you see over here, this is the main logic. I'm printing something and calling some val function, and passing these two values as a parameter. Some val will receive those values, and then it is validating x. Now validate is again another function which I have defined over here, and in that I am trying to see whether this information input variable is integer or not. If it is not integer, then addition cannot be done. If it is integer, then it will return true. True will come over here. This if will result in true. Similarly, if result in true, then addition will be done, and the outcome, the addition would return to this location over here. But in the second case, you can see that I am passing a string over here. So in this case, the return value would be that you please enter numeric value. Why? Because this is numeric, will return false. Okay. We can define modules. We can, in main logic, we can define how those modules would be used, how they would be used to compute something, and the results will be pushed back to the main logic for further computation. Okay. So we can represent this on flowchart as well. As you can see, this is sequence of modules. Different modules are being called in the mainline logic, and each module can be defined what that module is doing. And you can see that get input module basically takes in some print. First of all, print to user please enter value. Then it takes the value. Then it will whatever it wants to do, it will do it, and it will return to the main logic. Similarly, we have calculate average and print result statement over here, and this is the pseudocode of these modules. And this is about submodule. So these were the first hierarchy of modules, and within that hierarchy we further divided this get input module into two submodules, two subprograms, and then we define how each subprogram is working. Okay. So in short, the logic needs to be depicted on the flow charts that you want to get implemented by the programmer. Okay. So there is well-defined terminologies used when we call a method within another method. It's called encapsulation. Have you heard of this word before, encapsulation? Where? Object-oriented programming. Objects basically hide the information and functionality from other objects. So that is the idea of encapsulation. So same concept, same terminology is applied over here when a module is calling another module to achieve certain functionality. So breaking of these modules into submodules is a skill, it is an art. And we all know that you learn this art by doing the thing. Okay, so the more you work in industry, the more you basically come across these problems, the more you do analysis and design, the more you do design your flow charts, the better would you be in position to identify how these modules should be break into how many sub-modules and so on. So best practices, again, people define, then you start with the statements that you think are manipulating certain kind of information, put them together. For example, in case of transactions, all the instructions that are related with the credit information, put them together. All the instructions that are related with print summary, print report, put them together. And in this case, you also achieve functional cohesion. Cohesion and coupling, I'm sure you would have discussed, studied in system analysis design. How cohesive is the module is. If it's cohesive, it is doing one task, okay, and coupling is how much interaction is between them. So if you define too many modules, that is not even good as well, because there are too many modules, then management of those modules would be a key challenge. So what is the key balance? Again, it's depend on problem, your skill set, your experience, how much you basically discuss it with your team. Those practices basically ensures that the solution, the modules you have defined, they are up to a certain level of number that can deliver you the objectives you want to achieve. So we have to avoid both extremes, okay. So before going to variables, we can take 10 minutes break, and then we will start from here. If you have any question, I can answer that now. No? Okay, so we can have 10 minutes break, and then we will be back at 11:27.